Virtual Port Channel (vPC) versus StackWise Virtual Link (SVL). This presentation compares Virtual Port Channel (vPC) in Cisco Nexus switches and StackWise Virtual Link (SVL) in Cisco Catalyst switches. We'll explore the differences, advantages, and disadvantages of each technology. This will help network engineers and architects understand which to use for high availability and scalability. Understanding Virtual Port Channel (vPC). What is vPC? vPC allows links to appear as one port channel to a third device. These links are connected to two different Nexus switches. Offers multi-homing. Creates loop-free topology. Increases bandwidth. Supports active/active forwarding. Supported platforms. vPC is supported on Cisco Nexus 9000, 7000, 5000, and 3000 series switches. For example, two Nexus 9000 switches can form a vPC domain connected to a server. Exploring StackWise Virtual Link (SVL). What is SVL? SVL enables two Catalyst switches to operate as a single logical switch. It simplifies network design, uses a single control plane, provides stateful switchover (SSO), increases bandwidth. Supported platforms. SVL is supported on Cisco Catalyst 9000 series switches, like the 9500, 9300, and 9200. For example, two Catalyst 9500 switches can form an SVL domain. Key architectural differences. vPC, Nexus. Distributed control plane. Peer link for communication. Requires config sync. Independent forwarding planes. SVL, Catalyst. Single, unified control plane. Automatic config sync. Single forwarding plane. SVL acts as the interswitch link. vPC uses a distributed control plane, while SVL uses a single, unified control plane. This impacts configuration and management. Feature comparison. Feature. vPC, Nexus. SVL, Catalyst. Control plane. Distributed. Single unified. Data plane. Distributed. Single. STP dependency. STP free. STP free. Configurations sync. Manual/automated. Automatic. Management. Separate coordinated. Single. Primary/secondary role. Peer keepalive. Active/standby with SSO. vPC and SVL differ significantly in control plane architecture and management approach. Choose the technology that fits your network best. Advantages of vPC Nexus. Increased flexibility. Supports diverse topologies and incremental upgrades. Scalability. Scales well in large data centers. Granular control. Allows fine-grained control over traffic flow and policies. vPC is ideal for data centers needing high bandwidth and resilience. It eliminates STP complexities. Disadvantages of vPC Nexus. Complex configuration. Requires careful planning. Split brain potential. Requires robust config. Troubleshooting. Distributed nature. vPC requires careful planning to avoid split brain scenarios. Its distributed nature can complicate troubleshooting. Advantages of SVL Catalyst. Simplified management. Automatic config sync. Faster convergence. SVL offers simplified management and faster convergence due to SSO. It suits campus networks needing high availability. Disadvantages of SVL Catalyst. Limited flexibility. Fewer topology options. Single control plane failure. Impacts entire switch. Distance limitations. SVL link distance. SVL has limitations in flexibility and control plane redundancy. It's limited to specific Catalyst 9000 switches. Conclusion. Choosing the right technology. Evaluate requirements. Scale manageability. Consider skill set. Team expertise. Choose wisely. vPC or SVL. vPC is best for data centers needing scalability. SVL suits campus networks needing simplified management. Evaluate network needs before choosing.